Myself, JV Dr. Surendra Kumar Srivastava from the Department of Science under the Faculty of Education and Methodology, Jayoti Vidyapeeth Women's University, Jaipur. Today I will learn about the Cauchy sequence. A sequence AN is said to be Cauchy sequence if for given epsilon is greater than 0, there exists first number. A sequence AN is said to be Cauchy sequence if for given epsilon there exists a positive integer small m such that mod of am plus p minus am is less than epsilon for all p is greater or equal to 0, or a sequence AN is said to be Cauchy sequence if given epsilon is greater than 0. However small, there exists a positive integer m depending on epsilon such that ap minus aq is less than epsilon for all p, q is greater or equal to m. Now there are the remark. A sequence AN is a Cauchy sequence if for given epsilon is greater than 0, we can find a term am of the sequence such that the difference between any two terms of the sequence after this term is less than epsilon. For example, sequence AN, this is sequence 1 by n, so we can write sequence AN is equal to 1 comma 1 by 2 comma 1 by 3 and so on. If we take A20, then A20 is equal to 1 by 20 and A21 is equal to 1 by A21. Mod of A21 minus A20 is equal to 1 upon 21 minus 1 upon 20. This is 1 upon 4 to 0, so 0.002380. Similarly, mod of A22 minus A20 is equal to 1 upon 22 minus 1 upon 20. This is 0.0045 and so on. So we can write mod of AN minus AM is less or equal to 1 by 20. Thus we see that mod of AN minus AM is less than 1 by 20 for all n is greater or equal to m, where m is equal to 20, so the given sequence AN is Cauchy sequence. Let epsilon is greater than 0 be given, let n is greater than m and n is equal to 1 by AN is equal to 1 by n. Now AN minus AM is equal to mod of AN minus 1 by m is equal to 1 by m minus 1 by n. Mod of AN minus AM is equal to 1 upon m minus 1 by n is less than 1 by m. So we can write mod of AN minus AM is less than 1 by m is less than epsilon if m is greater than 1 by epsilon. For each epsilon is greater than 0, there exists a positive integer m such that mod of AN minus AM is less than epsilon for all n is greater than m. So we can write sequence AN is Cauchy sequence. Now we say the question, the sequence n square is a Cauchy sequence. This is true or false? Let AN is equal to n square, let p is equal to 2m plus 1 and q is equal to 2m, so that p comma q is greater than m. Now ap minus aq is equal to p is mod of p square minus q square. This is mod of p plus q and p minus q. This is ap minus aq is equal to mod of 4m plus 1. So mod of ap minus aq is equal to 4m plus 1 is greater than 1 for all small m belongs to capital N. If we take epsilon is equal to 1 by 2, it is not possible to find any positive integer m such that mod of ap minus aq is less than epsilon for all p minus q is greater than m. That implies mod of AN is not a Cauchy sequence. Now we will see a theorem, every convergent sequence is Cauchy sequence. Let sequence AN is a convergent sequence and limit n tends to infinity, xn is equal to L, then by definition we can find mod of xn minus L is less than epsilon by 2 for all n is greater or equal to m. Similarly, in particular case for n is equal to m, we have mod of xm minus L is less than epsilon by 2. Now capital M is equal to maximize m1 comma m2. Now taking x mod of xn minus xm is equal to mod of xn minus l minus xm plus l. Mod of xn minus xm is equal to mod of xn minus l minus xm minus l. Mod of xn minus xm is less or equal to mod of xn minus l plus mod of xm minus l. This is mod of xn minus xm is less than epsilon for all n is greater or equal to m. This is equation A. By equation A, we can say that sequence xn is Cauchy sequence. Now we will see the another theorem. A sequence converges if and only if it is Cauchy sequence. First, let sequence an be a Cauchy convergent sequence to L. We shall show that this is the Cauchy sequence. Let epsilon is greater than 0 be given, then there exists a positive integer small m such that mod of an minus l is less than epsilon by 2 for all n is greater or equal to m. In particular case, for n is equal to m, we have mod of am minus l is less than epsilon by 2. Now mod of an minus am is equal to mod of an minus l minus am minus l is less or equal to epsilon by 2 plus epsilon by 2 is equal to epsilon for all n is greater or equal to m. Thus mod of an minus am is less than epsilon for all n is greater or equal to m. That implies sequence an is the Cauchy sequence. Now conversely, let sequence an be a Cauchy sequence. Since every Cauchy sequence is bounded, therefore sequence an is bounded. Since every bounded sequence has a cluster point, Bolzano-Weierstrass theorem, sequence an has the cluster point L. We shall show that sequence an converges to L. Let epsilon is greater than 0 be given. Since sequence an is a Cauchy sequence, there exists a positive integer small m such that mod of an minus am is less than epsilon by 3 for all n is greater or equal to m. This is equation 3. Since L is the cluster point of sequence an, every NBD of L contains infinitely many terms of sequence an. That implies an belongs to L minus epsilon by 3 comma L plus epsilon by 3 for infinitely many values of n. In particular, we can find a positive integer small k is greater than m such that a k belongs to L minus epsilon by 3 comma L plus epsilon by 3. This is equation 3. And mod of ak minus L is less than epsilon by 3. This is equation 4. Also, since k is greater than m, therefore from 3 we can write mod of ak minus am is less than epsilon by 3. This is equation 5. Now mod of an minus l is equal to mod of an minus am plus mod of am minus ak plus ak minus l. That implies mod of an minus am plus mod of ak minus am plus mod of ak minus al is less than epsilon by 3 plus epsilon by 3 plus epsilon by 3 is equal to epsilon. Thus mod of an minus l is less than epsilon for all n is greater or equal to m. So sequence an is converges to L. Thank you.